This presentation is titled IT Thinking for Professional Media. I'm Brad Gilmer with Gilmer & Associates, and the presentation and a companion paper are co-authored by myself and Grant Hammond of Grant Hammond Consulting Limited. To be clear, I am making this presentation as a consultant with Gilmer & Associates and not in any role associated with any other organizations. This presentation builds on ideas presented in a paper titled Agile Media Blueprint, co-authored by Dr. Richard Cartwright and myself. That paper may be found at the URL below. This presentation is divided into two parts. The first part looks at what it would mean to adopt IT thinking for professional media. The second part looks at applying specific IT principles to building composable media facilities. In any technical project, it's really a best practice to begin with business-driven end-user requirements, and in this case we've collected a number of business-driven problem statements from different end users in the community. The first problem statement comes from Richard Friedel at Fox Television. Richard says, I want to be able to swipe a credit card and turn up a service. When I'm done, I want to be able to pay for what I've used. No capital expenditures. What Richard means here is he wants to be able to try out a new offering for customers at home. If they like that and the offering is successful, that's terrific and that service can grow. If it's not successful, they're able to shut the service off, only paying for what they've used. Gordon Castle says, for Eurosport's next set of facilities, we want a cloud approach for physical kit. We want common access to all content, and we want distributed operations that delivers remote production for all. We're building a private cloud for live production. In my former role at Turner Broadcasting as the head of engineering and operations for the entertainment division, I frequently found myself being Dr. No, always telling people why they can't do something. And that was because we had such high upfront costs that it was really prohibitive to try out new ideas and just see if they would work. I want an infrastructure that has much lower upfront cost and allows me to dynamically try out new ideas and see what works. As many people know, our colleagues at CBC Radio Canada are making a massive investment right now in new facilities. Francois Vaillant says, we're investing in a massive IT-based facility. We hope that over time the industry adopts more IT thinking to allow us to innovate based on the infrastructure we're building now. So specifically, they're building a facility based on the technology available today, but they're looking forward to the point where they can adopt more IT thinking and leverage the investments that they've made in core IT infrastructure. So what's the problem? What's wrong with where we are today? Speaking bluntly, the IP transition has been long on promises and short on value to end users. And I'm saying IP rather than IT here. Specifically, IP is not delivering the ilities that a number of users are really asking for. Agility, flexibility, composability, reusability. It turns out that IP is not necessarily less expensive to build. It's not bill per use, as Richard Friedel was talking about earlier. Honestly, it's not easier to implement. And critically, it's not easier for IT people to understand. So if you get an IT person and you introduce them to ST2110 Essence, PTP, that tell them that there's no HTTPS, there's no DNS, no DHCP, node balancing, they're really not going to understand why it is that you're building facilities this way. And lastly, it's not leveraging internet technology. So how can users achieve the vision of flexible, composable facilities? What is the solution for the problems that were listed on the previous slide? In a nutshell, I believe it's adopting IT thinking for professional media. So what do I mean by that? I mean we should be stealing everything from the IT domain. Everything that we possibly can in terms of their best practices and technologies. We need to automate everything. Even the simple things need to be automated. In fact, a colleague of mine who works for a very large IT internet company says that when you're automating something, it may be tempting to automate those things that you do over and over. But really, you should automate even the most simple tasks that you think you're only going to do once. Because if you're doing something only once, you're not that familiar with it, and you may make a mistake. And if you've automated it, you can go back and correct that mistake. And then if you ever have to do that operation again, you know how to do it correctly. And finally, we need to start with security. We've learned that security is very hard to build in after the fact, and many IT solutions begin with security. So this sounds simple. IT and computer science are focused on delivering the ilities at scale. Microservices are the next big thing. There's a huge pool of smart people that already have adopted IT thinking, and they work with IT every day. So why don't we just apply IT thinking to professional media? That's great, but how do we do it? In an earlier slide, I said we should steal everything from the IT domain, especially best practices. And you may be wondering, okay, but anything specific? Well, yes, I brought a list. In IT thinking, it's very common to consider anything that's available for you to use as a resource. That resource in professional media could be a transcoder, it could be a wipe effect, it could be some sort of other maybe cloud-based resource that's available for you on a licensed basis when you need it. One very liberating and important fundamental concept in the world of IT is that resources are independent of location, form, and function. And in a nutshell, what this means is that as a user of a resource, let's say a wipe effect, you really don't care where that wipe effect is coming from, how it was created, whether it was some sort of hardware effect or a software effect or whatever. And you really don't care what functions were used to create that wipe effect. All you care about is that you get that wipe effect when you ask for it. And this decoupling of the notion of the delivery of a resource compared to the delivery of an effect from a box in rack 12 is a very important decoupling in IT thinking, and it's really critical for us to start thinking in this way. A number of the other points on this slide relate or build off of this notion of the resource independent of location, form, and function. A mutable identity refers to assigning an identity to a particular resource and then never ever changing that identity for the life of that resource. So if you are looking for a particular wipe effect, you should always be able to use a particular identifier to refer to that resource, and you should always get back that specific wipe function every time you call it with that identity. And so you could assign multiple identities to the same wipe effect, let's say. But the point is that if you use that identifier, then you should always get the same result. You can imagine that when you create a unique identifier to assign to a resource, that those identifiers can be pretty hard for humans to read. In fact, you've probably seen UMIDs written out, and those are pretty hard to commit to memory. They tend to be pretty long and don't have any human readable notion in them. So the idea of names makes resources easier for humans to identify. It also provides a kind of an organization and classification for resources. Think about a web page, for example. You might go to a web page with the domain name, whatever that might be, and then under that domain name, you might go to projects slash project, my project, let's say. That name is an easy name for you to remember, my project. It's classified under projects, and it's a project that's taking place within this domain. And that classification is extremely important and has really been one of the primary empowering things behind the development of the internet. But URLs used in web pages are only one kind of URN. And so it's important for us as an industry to really understand and adopt the power of names that's been used for quite some time in the IT world. DNS and DHCP are two important core services available on a network, and they make our lives easier in the professional media space in a number of ways. First of all, domain name services resolve a name to an IP address, and that's important because for us, again, as humans, if you're typing in IP address, you may be able to remember it, but once systems become large, it's a lot easier to type in the name of something like your broadcaster slash transcoders slash AVC transcoder than it is to try and remember a large number of IP addresses. Now, one of the things about DNS that's important, coming back to this notion of resources independent of location, form, and function, is that if you're looking for an AVC encoder, let's say, it really doesn't matter to you which specific transcoder or encoder you get, or I would argue that it shouldn't in a well-designed system. If this is true, then when you make a request for that slash AVC transcoder, the domain name server can give you any one of a number of AVC transcoders that will meet your requirements. This allows all sorts of things, including load balancing and taking devices out of service for repair. DHCP really frees humans from a lot of the manual configuration in IP systems, and it's another core part of IT thinking. Now, it may be very important for us to assign IP address spaces based on all kinds of things in a professional media network. But when we first bring a piece of equipment up online, it is extremely handy to be able to plug that piece of equipment into a network and have it come up and be addressable on the network without having to go in and manually configure every IP address. Once that device is up, then we can go in and assign it to whatever address space we want. But the power of DNS and DHCP are core to IT thinking, and we should be looking for ways where we can leverage that power in the media space. Idempotency is a key component of IT thinking. It refers to being able to execute a command once, twice, 50 times, and still have the same result. Let me explain that a little better. In idempotency, if you say you want to set a variable to 1, and you do that, that variable should remain at 1 whether you execute that command to set that variable to 1 time or 100 times. At the end, if you examine that variable, its value will still be 1. And this is very important because in some loosely coupled systems, you don't know exactly in which order certain things will finish. And so idempotency keeps from breaking these sort of more loosely coupled systems. Stateless machines relates to the point of idempotency above. It means that you have a small piece of code, some function that does something, and if you are interacting with that device, you do not have to know the state of that machine before you interact with it. And in larger systems, this means that you, as the overall application, do not have to keep track of everything that's happening in the system. And that means that when you finish some operation, you can go make some entry with this machine without having to worry about what has happened in that machine previously. So idempotency and stateless machines, those concepts go together. Eventual consistency is a concept that came up in IT as we began to work databases extremely hard, much harder than we had ever seen before the internet was developed. I'm talking about Twitter volumes here, millions of operations per second. When you have that many operations going on in a system, it's impossible to keep a database, a single database, completely accurate all the time. And so having mechanisms in place that ensure that a database that might be spread across different locations or different servers will eventually be consistent, but at any one time there may be some inconsistency between those databases, is a very liberating thing that allowed a quantum leap in the size of computing that can be done in the IT environment. And in media operations, it may be that we end up with tens of thousands of operations per second, hundreds of thousands of operations per second, and even medium-sized facilities. And so eventual consistency could be a very liberating and important IT concept. At the beginning of this presentation, Gordon Castle talked about cloud thinking for physical kit. Thought I'd explain that a little bit more here. The notion is that even if you have physical kit, even if that is some sort of media hardware device that is not at all adapted for operation in the IT world, rather than approaching this as something that limits the entire design and architecture of the facility, think about how you could wrap that device so that it appears more IT native and more cloud-like, meaning something that could be brought online on demand and then released when it's not necessary. This sort of thinking allows you to move forward with plans to adopt IT thinking rather than being stymied by the fact that you're going to have legacy media-specific, non-IT friendly kit around for quite a while. We know that in our industry, we do all sorts of different things with media. We interact with the video in particular ways. We do audio manipulation. We have data that appears on the screen in various ways. And when we perform operations on these different essence types, which we frequently do in media operations, we're usually transforming that essence in some way or other. And it could be very useful to model these transformations as a string of discrete things that operate on the media essence. And having a consistent way of referring to these could allow us to be able to chain these different sets of transformations together into workflows. We'll talk more about that later. And I'm sure as we start talking about modeling individual transformations, you may have started thinking, well, is this a microservice? Well, it might be, it might not be. But certainly microservices are a best practice in the IT world. And when we talk about microservices, we're talking about a unit of code, some sort of service that's available in the cloud or on a network. It does one thing very well, and that's why it's called a microservice. And so the idea of being able to chain together these transformations as microservices into composable workflows is extremely powerful and certainly something that we should be looking at in our industry. When you interact with any sort of service on a network, you typically do that through an API. And as you interact with more and more APIs from different systems, it becomes a real cost to develop these APIs when they're very poorly documented. And in fact, the IT world has understood this for a long time, and they've developed whole integrated development environments that make it very easy to integrate some sort of new service into an application, especially if those APIs have been self-documented. And also, importantly, if those APIs control services that do not do too much. And so having microservices with APIs that are simple and that are documented in the API itself rather than having external documentation somewhere, these are all best practices that have really allowed the IT world to adopt a plug-and-play approach, or almost a plug-and-play approach. It's really simplified the development of interfaces into services in a complex IT environment. One other thing I would just throw in here is that frequently in API development, people will write the test for an API or for a whole service before they actually write the service and the API itself. And in this way, they're able to validate immediately that the service is doing what it should do and that the API works correctly. And when they publish that service with its API, you automatically have a test suite that comes along with that to validate that it's working correctly. And this is an area where the media industry could really do a lot better than it has in the past, and we could really learn a lot from the IT industry in this domain. When we talk about timestamps and buffers and synchronizing different essence types at presentation time, or at the time that you're going to use multiple flows, this is a liberating idea in IT thinking that we also really need to push our boundaries on. Especially, I would challenge users. We keep coming back to needing real-time video and audio, and how important that is in many applications. The fact is that having video and audio tightly in sync all the time as that material is streamed from one place to another, they're really a very narrow corner case of applications where we have that constraint. And if we were able to think seriously before imposing that constraint on manufacturers, we would get some really interesting systems that do much different things than they do today. And I think you would start to see pull type technologies for streams rather than having as many push streams as we do today. That really opens up the use of internet technology for professional media. So if we could really think carefully about how we could use timestamps and buffers, and when we really have to impose that real-time constraint and not just use that constraint very loosely, then we could open up a lot of new operational possibilities in our facilities. One topic that was discussed in the Agile Media Blueprint paper that I'd like to reintroduce here is the notion of a uniform way of modeling operations that we perform on media, and the notion of composable media services. If you look at this drawing, you'll see that we have a function, some sort of transform, and that transform takes content or essence in. The transform is performed on that content, and then the content goes on to another operation. There's an ID associated with this transform, and if you remember the notion about immutable identities and naming, we can always ask for this particular transform by its name, and we'll always get back this particular operation every time we ask for it. We interact with this transform, maybe setting different parameters for it through a content API and a uniform interface that complies with what we were talking about earlier about self-documenting well-written APIs. So this could be a ubiquitous media service model. It has a self-describing interface to it. It's atomic. It doesn't do too much. And this media service, as we talked about before, exposes a capability like a video fade. You could call it a microservice if you like. As we talked about in the previous slide, you can chain these transforms together by calling those transforms up by referring to their IDs. And as I said before, if you ask for these transforms by their unique IDs, you will always get that particular transform that you're looking for. And so we can chain these transforms together into different workflows to perform different functions on our media. Importantly, once that workflow is done, we can release those resources in these transforms back into the service layer, and then later we can call those particular transforms up or maybe combine them with other transforms such as here where we've reused transforms A and C but in a different order, and we've dropped transform B and substituted transform F instead. And so we can put these composable media services together in different ways to perform different workflows. Now that we've described the characteristics of a composable media service, and at a high level, we've looked at how these composable media services could be chained together to achieve a particular media-based workflow, let's get to some of the details about how you would actually put these concepts into use. So we're going to start building on these ideas and start thinking about how we could actually expose certain capabilities and how we might then be able to consume those. So in this slide, we have a drawing which shows a couple of different layers, a business functions layer, where you have an application or a task, something that you want to do related to media. And below that, you have a service layer with media devices that are capable of doing different things. So, as we said, media devices exist in the service layer, and that media device offers up a capability as a service. The application at the business layer needs to consume that capability in order to perform its task. And when it's finished, the capability exposed by that media device basically dissolves back down into that service layer where it can be used for some other function or some other workflow at a later time. You might be saying, well, this idea of adopting IT thinking for professional media is wonderful, terrific. But can we please get specific? Could we address one specific area and see if we could drill down and actually put these principles into action? When we start looking at that, a number of questions arise. The first obvious question is, can we actually do it? Can we actually develop an architecture that applies these principles? Another question is, if I reuse resources, how do I know the resources will be available when I need them in the future? It's not acceptable to plan for some sort of a critical, let's say, sporting event, and then find out 2 hours before error that the facility can't be built because particular pieces have already been used somewhere else. Can we build facilities just in time? And if yes, how? This is a major shift in thinking from facilities that we build and then they may be used for years at a time. And can this work in an on-premises, off-premises, cloud, and multi-tenant environment, all combinations of those? And there are even more questions. It's one thing to build a facility that has a lot of composable media services. It's completely something else to be able to expose those capabilities in a uniform way so that other applications that want to make use of those capabilities know they even exist. And how do I interact with the media device once I understand that the capability is available? Do I have to interact with each media device in some different way, some fundamentally different programmatic approach? And finally, is there any existing work we can build upon as we look at applying IT thinking to professional media? So the good news is that there is some work that we can build on. If you go to jtnm.org, that's jt-nm.org, you can find the JTNM reference architecture version 1.0. And in there is a model. And so I've pulled out a little bit of that model and adapted it for this presentation. And it talks about offering and consuming services. So let's take a look. We said that media devices offer up a capability, and if you look at this UML fragment here, you can see the media device at the bottom of the drawing, and then to the left, you see that it offers up one or more capabilities. Those capabilities are resources that can be registered in a registry. And we can imagine that in any large facility, you may have more than one registry, and so you'd need a federation of registries if you were going to be able to search across those to find the capabilities that you're looking for. When you want to interact with this media device, you can see that the media device has one or more endpoints that offer up capabilities, for example, keying or layering. As we had said before, you have an application task that you want to perform that's residing in the business layer. And so that application task would then interact with the device through the endpoint control interface. So now that we have introduced a number of key concepts about using IT technology and basically stealing everything we can from their list of best practices and applying it to media. And we've talked about the notion of composable media services, the way that you might find those media services in a system and then consume those. It might be useful to start the second phase or the second part of this presentation and look at a worked example of how these concepts really could be put into use in a real-world scenario. So we'd like to introduce the dynamic media services architecture, and the purpose of talking through this is that this is a real-world example of how you might apply all of these IT concepts in a real architecture. And I should say that a significant amount of work has gone into this architecture because we really wanted to push past just a simple PowerPoint presentation and get into some real architectural modeling of the capabilities, the systems, the layering of how things would really need to be in a system that employed these concepts. So let's get started by talking about what this architecture enables and what problems it solves. So what problems do the dynamic media services architecture address? What does this enable? The first is that it enables having human interfaces in physical locations that are connected to the processing back ends dynamically as needed, and that the human doesn't necessarily know exactly which device in which rack a particular control interface like an audio console or a switching console is connected to, because ultimately the human operator running that cares that that device in front of them, that interface in front of them, exposes the capabilities that they need. They don't really care as long as it does what they need and it performs according to the sort of responsiveness and other human factors that the operator requires there. They don't really need to know, and they don't really care where the engine is located that's connected to this front end interface that they're working with. So as a result of this, the control surfaces are no longer hardwired to equipment in a particular rack. It also enables the creation of right-sized facilities. So imagine that someone is going into a control room. All they need are 2 MEs of a switcher. They need an audio console with a certain number of inputs, let's say 16 inputs, and they need maybe a graphics engine, graphics workstation there. In a traditional facility, they would, in an ideal world, that's exactly the composition of the production facility they would have when they walked in the room, but they may actually have a 3 ME switcher. They may actually have a 64 input console, even though they only need 16. Yes, they may have the graphics workstation, but they might have all kinds of other graphics capabilities, still stores, and all kinds of other things that they don't need. And for the time that that production room is in use, those excess capabilities are unavailable to anyone else in the facility. And so one of the things that we wanted to do in this model was to enable delivering the amount of technology, the amount of capabilities that's needed for the particular job at hand, and not more. We wanted to have the capabilities appear in the facility at the time that they were needed. Of course, the facility would need to be built. When you say built, we mean virtually the connections made, the backends associated with the user interface devices in a particular control room, for example, to be made ahead of time. But when we say ahead of time, it might be 4 hours before a big show. It might be the night before a big production. But it wouldn't be 6 months before. And if you had a facility that operated like this and the operators gained confidence in it, it might be that this facility was actually built maybe only a couple of hours before. And otherwise, the back-end capabilities that are in the facility could be used for other things up until the time that they're actually needed. Another important concept here is, if you remember, we talked about a service layer with media devices that reside in that service layer, and that those capabilities in those media devices are offered up when they are needed. So those are latent capabilities that are in the service layer that can be consumed on demand. But imagine that those capabilities actually existed in the service layer as licenses, and they were not actually hydrated or created, or the licenses were not associated with a particular instance of an application until it was actually needed. So the notion is that these licenses, these capabilities in the service layer, could be hydrated on demand, almost like you have dry food that's available, but it's certainly not ready to be eaten. But if you add hot water to it, then it becomes available and you can use it. This opens up a number of interesting other business opportunities. For example, the thing that Richard Friedel was asking for, which is billing based upon services consumed. So you can imagine a licensing model where the users are billed based on actually standing up services. And it could be that, yes, less income is available because the services are used less often, but it could also be that a particular service that is launched by a media company becomes tremendously successful, and actually you need more capability. And so this ability to scale up and scale down and pay for what you need is actually a well-tested and well-supported model, and a number of best practices have supported this for a number of years in the IT world. And we're looking at whether you could actually support those sorts of things in the media environment if you adopted a number of the things that we talked about in IT thinking for media in part one of this presentation. I've found that it's really important, especially in the engineering discipline, to understand what sort of problems you're trying to solve with a particular technology or architecture before you go charging off and attempt to build it. So this slide covers a number of problems that the dynamic media services architecture addresses. So first of all, it's a way to dynamically provision media services. This idea of having services in the service layer, capabilities in the service layer that can be consumed and then released. Importantly, we talked about how you would know that capabilities would be available in the future. Well, this architecture tracks future commitments for resources in the service layer. It supports the dynamic facility concept that we talked about before, where facilities are created, the workflows are put to work, and then that workflow is decomposed and those services basically sink back down into the service layer to become latent and available for use later. It enables rolling upgrades. If you think about this, if you have a media device or many media devices in a service layer, and those capabilities from those media devices are made available as needed, then one simply needs to mark a particular media device or a particular service as being out of service and unavailable in a way that allows it to be upgraded. And then once the upgrade is performed and the functionality of that media device is confirmed to be okay, then you could mark that media device as again being online and available, and then it could be consumed again as part of a workflow. It allows monitoring of service utilization over time. And this is a key concept from the IT thinking that enables different billing models, different licensing models based on consumption of services rather than just based on the latent capability in your facility. It supports affinity and fallback. Affinity gets to the part I was talking earlier about where you may have a user interface in a control room, and in order to meet response times for the user, meaning that they push a button and something happens on a screen within an acceptable range of delay, it may be that the services that and media devices that are allowed or preferred to connect to that user interface come from facilities that have a certain maximum amount of delay associated with them. And so when I say, and usually these delays are associated with distance. So if I have, for example, 3 or 4 engine rooms located in different countries, then it may be that I only allow control rooms and physical user interfaces to connect with devices, back-end devices that are in my country or near my country. And so these affinity rules would say that the first place I'm going to try and connect this user interface device to is going to be someplace nearby. But it could be that those rules can be violated. For example, if a particular facility is offline, it may be that you decide, I'm going to accept the delay of connecting this user device to something that's far away because I have no other alternative. And in this disaster or emergency situation, for example, then at least I'm on the air. And this could happen automatically, actually. Again, this is a fallback scenario where it may be that some particular large facility has gone offline, and you just automatically fall back to devices that have similar capabilities, equivalent capabilities, but are only used when the closer devices are unavailable. This system, this architecture permits manual intervention at every step of the way, and while we believe that high levels of automation could be supported with this architecture, we completely understand that there are going to be times when the requirements of particular workflows are going to require a human in the loop at some point. And so human intervention is supported here. And importantly, we believe that the DMS architecture provides a clean, layered model with a proper separation of concerns and clear delineation of functionality in each layer, and that the adoption of this architecture generally in the industry would really help both manufacturers and users to build facilities that are that work better, are more resilient, and that are easier to maintain and automate in the long run. Let's start with a really high level generic view of any media business you can think of. When we look at the media businesses generally, the core business is focused on obtaining or creating and then monetizing media content. That really is the media business. Below that, the company will use certain business functions, for example, editing, live production, show planning, etc., in order to achieve the goal of monetizing content. Below that, certain services provide capabilities to these applications in order to enable the business functions. And at the bottom, there's a physical infrastructure layer. No matter whether you're talking about on-premises, off-premises, in the cloud, there's still a physical infrastructure that consists of IT equipment, fibers, and a number of other things that are required to actually do the work. In this layer, we introduce a key concept, and that is that services provide capabilities to enable business functions. And this is a core concept that it would be helpful for you to bear in mind as we go through the rest of this presentation. In addition to the media business high-level view, we also want to introduce a business process cycle for media. This typically begins with planning using facility scheduling systems. Then in our architecture, we have a provisioning layer which involves actually scheduling media services to be used at a later time. We then have a construction step, which is performed by the media system constructor, which actually builds the system as requested sometime before it's needed. We then have a control step, and this control step typically is a handover to the systems that do real-time control of broadcast operations. So, put another way, you would plan for an event, you would provision equipment for that event ahead of time, you would build this facility, and then you would hand over the control to the different user interface panels, automation systems, and other live or closely timed control systems to actually do the control portion. Once the event is finished, or you're ready to take a particular system offline, you go to the deconstruct phase, and this step is performed by the same media system constructor that built the facility in the first place. In this slide, on the left, is the high-level media business view that we presented earlier, and on the right is the dynamic media system architecture. And as you can see, the two correspond. At the top level is the media business, then are the business functions. The service layer that provides capabilities to the media applications is shown in red here, and then the physical infrastructure is shown below that. Now we'd like to introduce for the first time the dynamic media services architecture. We're going to go through this in extensive detail, so we'll just stick with the high level for right now. If you remember the cycle that we talked about before, that's reflected here. The planning part is performed by the facility scheduling layer. Provisioning is provided in the media service provisioning, or the MSP layer. Construction is also in that same layer, that's why we have it in the same color, through an entity called the media system constructor. And then the live real-time control we talked about reside in the facility control layer. Now let's focus on planning and contracting. A planning system, such as a facility scheduling system, is going to request a kind of resource, such as a control room or satellite receivers, whatever it might need for a particular event that's going to happen. The Media Services Provisioning System, or the MSP, checks the resources and a diary to see if the resources that the planning system is requesting are available. And then the MSP issues a contract to the facility scheduling system for that particular resource to be executed at some time in the future. At some time later, perhaps as much as a month or even more, it's time to actually build the facility. And the initiation of this construction can either be started by some sort of automation system, or it could be done manually. But in any case, at some point, the system constructor receives instructions that say, build this facility now. The media system constructor checks with the MSP layer, and at this point, the MSP provides the specific instance of the kind of resource guaranteed during the planning process. The constructor then builds the workflow from the various media devices that are allocated by the MSP. It's very important to understand that when the facility scheduling system first asked if a particular resource was available, it asked for a kind of resource, like a satellite receiver or an ME. It didn't ask for a specific satellite receiver or a specific switcher component in a rack. And it's the MSP that actually acts as a resolver, resolving the kind of resource request, like a request for a satellite receiver, to an instance kind. You may use satellite receiver 6 in this instance. So this notion of a the MSP acting as a resolver, is pulling in a key concept from the IT world that's used in many things, among other things, DNS. As we mentioned before, once the constructor is finished building the facility, then control is passed to the real-time control applications. For example, a production control room or an edit suite or a master control. And during the operation of the facility that the media system constructor built, these real-time control systems are the ones that are in control and issuing commands to the actual media applications. When the event is finished, the constructor is called again to deconstruct the workflow, and the services are released. Importantly, then the media service provisioning layer notes that these resources are free and available to be used somewhere else. Here's another more detailed view of the dynamic media system architecture. It's been reordered, and we've added detail showing a number of additional functionalities that are required in each layer. We're going to go through these layers in detail in a moment. Here we see the media business and business function layers. And as we discussed before, at the top is the media business that's looking to monetize content. And then below that are the business functions that are used to actually achieve the goals of the media business. And you can see that in the DMS architecture, we include not only technical workspaces, which are shown on the right, but we also include office workspaces shown on the left here, because those include important components in any media business, including the scheduling, commercial sales, and so on, that really create the demand for media services that need to be filled later, lower in the architecture. And then the technical workspaces shown on the right are what you would expect. Studios, edit facilities, voiceover booths, graphics, playout, and so on. So now we're working our way down through the DMS architecture from the media business and business function layers down to the services layer presented on this slide. We've included in the services layer the business systems such as SAP for HR and finance, contract management, rights management, media planning, commercial sales, and program scheduling, because these are the business systems that drive the demand for the scheduling of facilities, which in turn drives the demand for the services from media devices that are needed in order to create the products that allow the business to monetize its content. As I mentioned earlier, we have reordered the high-level layer drawing that you saw earlier. And in this case, we are showing that the facility control, the real-time control systems, which consist of a number of components, which we won't go into in great detail here. That facility control layer interacts with the media services once the facility is built in order to actually produce the content that we talked about. And so a number of these systems, such as vision mixing, audio, graphics, and so on, signal processing, these are all going to be controlled in the control layer, just as it might be controlled in a normal facility today. Working farther down the stack of the DMS architecture, we get to the infrastructure layer. And this is, I think, where the critical parts of the architecture lie, at least in terms of allocating resources and then making sure that those resources are available for later use. A big key to this whole infrastructure is this media services provisioning layer. And if you remember, during the planning process, the facility scheduling system will ask the media services provisioning layer whether certain services will be available at some point in the future. And as we mentioned, this system in the media services provisioning layer is going to check its resource diary and its resource catalog, which are shown here in this diagram. And based on future commitments and the resources that are under the control of this MSP, it's going to issue a contract through the service contract management module back to the facility scheduling system, letting it know that it can fulfill or it cannot fulfill the requests. Moving on through this, you can see a rules engine with the affinity rules that we talked about earlier. You may also have different geo rules. In other words, certain productions may not be allowed to be produced in certain countries or use equipment or have signals pass through certain countries. And then there may be room to equipment mappings, rules, and templates, since we know that physical user interfaces are in particular rooms, and it may be that you get requests from the facility scheduling system that says that Brad strongly prefers to use production control room 12 when he works. Then these rules can be built in to this rules engine, and in this way we can accommodate requests for specific rooms, and we can also know where particular interfaces or human interfaces are located so that we can connect them to the proper back-end resources. And then, as we mentioned earlier, there's the system constructor, which builds the system. The flow grouping maker is responsible for keeping track of associations between videos and audios that otherwise in a pure IP facility would just be unrelated. And clearly it's important to have a system somewhere that's keeping track of maybe the fact that these groups of videos and audios are all coming out of production control room 12, for example. There's also the notion that the system constructor stores user configurations, and as the facility is being built, we can automate as much of the setup of this control room as possible so that the people that move in to actually use the facility have the minimum amount of setup to do once they get in there. There are a few other aspects to this MSP layer. We're not going to get into that right now. Below this is a server virtualization and provisioning layer, which recognizes that not all of the services that need to be consumed will actually be provided from physical kit. In fact, it's highly likely that many of the services that are required in a facility will be virtualized. And so the media service provisioning layer interfaces with server virtualization and provisioning, spinning up and spinning down instances of particular media devices on demand. So we get down to the network provisioning layer. Remember, everything is a resource, and it may be that in your facility there is no way that you could run out of network bandwidth. Basically, you've taken an approach of over-provisioning your network. And if that's your approach, then you may not need network provisioning. On the other hand, if it is not the case that you have an infinite amount of bandwidth, then as the media services provisioning system is getting requests from the facility scheduling system, it can actually check with the network provisioning system, and depending on how you design these systems, it could be that the MSP layer keeps track of the total amount of networking consumed, or it could be that the network provisioning system actually tracks its total commitments for bandwidth in the future and issues a subcontract back to the media services provisioning layer saying, yes, I can guarantee you that, let's say a month from now on Thursday from 4 p.m. to midnight, I have enough networking bandwidth to support the request that you're making. This is not unlike the way that a building is built. A contractor will issue a guarantee to the owner of the property that they're going to build a house by a certain amount of time. But that contractor may have several subcontracts with specialists who are going to do the electrical, the plumbing, and so on. And in this case, the network provisioning system is responsible for keeping track of its own resources and issuing subcontracts to the MSP. And the MSP can then make a contract back to the facility scheduling system, just like a contractor would make a contract with the owner of a property to build a house. Below the network provisioning layer, or as part of this, we show an endpoint orchestration and SDN, our software-defined networking controllers, and many systems make use of this. Many system designs make use of this, and of course this would be part of the network provisioning. And then we show the AMWA NMOS ISO4 device registry, which is the place where this system will know which devices are available for use. And so in real time, this ISO4 registry can keep track of the devices that are available for use. Now, whether architecturally you would have an SDN system that would actually make connections between devices, or whether you might use the NMOS ISO5 API to make connections between devices, is really an implementation decision. Then below that we have processing hardware, those things that are not virtualized, things like servers and dedicated hardware or fixed function hardware. And lastly, below that we've got the networks. And in this case, many major media facilities have three separate networks at least. One is an amber or blue network, two networks redundant to move essence around, and then a general purpose or control network, which is used to handle control signals. So that's the infrastructure layer. This last slide addresses the question of multi-tenancy and whether it would be possible to build a facility where you perhaps had two data centers or large technical facilities for all the back-end equipment, and then you could have your own operation, and then perhaps several other tenants that would be operating off of these same back-end systems as well. If you remember, we said we reordered the DMS architecture. The reason that we reoriented that, reordered it compared to the original view that we provided you, is because this is how you would support multi-tenancy. So if you see at the top level, we have the business functions and the services that are necessary to support each of these tenants. And at the back end, we have the Media Production Services Cloud, which would consist of the services and infrastructure that are required to offer up the services to the capabilities to the services and the business functions up above. So I know this has been a long presentation. Thank you very much for sticking with it. If you remember, in the first part, we stressed how important it was to adopt IT thinking for professional media. And there were a number of very specific suggestions that we have about what parts of IT thinking are likely to be useful for the professional media industry. There were a few key concepts. Services provide capabilities to enable business functions. Bear that in mind. The reason that's important is because if you do not violate that provision, then you're able to provide those capabilities regardless of where those services are coming from. And services may be swapped, they might be in different locations, and a lot of flexibility is provided through that abstraction. Microservices with self-describing APIs enable composable workflows. They don't just enable composable workflows, they enable many other things. They enable the ability to write clean APIs that are easy to understand. They enable the opportunity to test API and media system functionality in discrete pieces, and they enable someone who's trying to troubleshoot systems to understand individual operations in isolation when they're trying to work out a problem. Media service provisioning resolved general requests for a kind of service to a specific instance of a service. So the media service provisioning layer acts as a resolver to resolve a request for a kind of resource, like a satellite receiver, to a specific instance of a satellite receiver at build time. The second part of this presentation shows how these concepts of IT thinking may be applied to professional media in a real-world scenario at a level of detail that we hope it proves to be useful to you. We hope that you've enjoyed this presentation. We have a paper that we are working on which covers the information in this presentation. The paper is not done yet, but we hope to publish it fairly soon. If you have any questions, feel free to contact myself, Brad Gilmer, or Grant Hammond at Hammond Consulting Limited. Thank you so much.